Troubleshooting Approaches. About this module. Welcome to the Troubleshooting Approaches module. In this module, you'll explore various troubleshooting tools and their functions. You'll also discover troubleshooting methods and when to use them. You'll deepen your understanding of troubleshooting approaches such as the CompTIA troubleshooting methodology, the Open Systems Interconnection, OSI, model, and the define, measure, analyze, improve, and control, DMAIC, approach. You'll learn how to apply each to various troubleshooting scenarios. Learning objectives. After completing this module, you should be able to choose a troubleshooting tool based on a scenario. Identify general troubleshooting methods. Apply the CompTIA troubleshooting methodology to a scenario. Apply the Open Systems Interconnection, OSI, model to a scenario. Apply the define, measure, analyze, improve, and control, DMAIC, approach to a scenario. About this lesson, Introduction to Troubleshooting Approaches. Picture yourself as an IT support technician. You are working directly with users and systems facing diverse technology challenges every day. These problems and issues form the foundation of your career, and the ability to troubleshoot is your most crucial skill. Imagine a system failure that interrupts a vital client call or a software glitch that jeopardizes a major project deadline. Such situations are not just inconvenient but can have a significant impact on business operations. As an IT support technician, you're the one responsible for solving these issues. In this lesson, you'll learn about common troubleshooting tools, including hardware, the command line, and remote troubleshooting tools. You'll also explore troubleshooting best practices and general troubleshooting methodologies. Before you begin, an important step in learning something new is understanding the terms people use in the profession. This is particularly important in the technology industry. Here are some common terms and their definitions that you'll see throughout this module. By familiarizing yourself with these terms, you'll be better prepared to learn the skills needed to become an IT support technician. Troubleshooting Approaches. 1. Module 1 Terms. Command line, a text-based tool technicians use to control a computer. It's like using your computer with text commands instead of a mouse and graphical interface. CompTIA troubleshooting methodology, a 6-step process for troubleshooting that is widely used by IT professionals. It involves identifying the problem, establishing a theory of probable cause, testing the theory, establishing a plan of action, verifying full system functionality, and documenting findings and outcomes. Define, measure, analyze, improve, and control, DMAIC, approach, a problem-solving approach that is often used in quality improvement projects. It involves defining the problem and its scope, measuring the current performance and collecting data, analyzing the data and identifying root causes, improving the process by implementing solutions, and controlling the process by monitoring and sustaining the results. Divide and conquer, a troubleshooting approach that breaks down a system into smaller parts to isolate issues. Hardware tools, tools that technicians use to analyze issues with devices such as a computer, smartphone, or network hardware. Internet protocol, IP, address, a numerical label assigned to each device connected to a computer network that uses the IP for communication. Media access control, MAC, addressing, a unique identifier assigned to a network interface. Controller, NIC, for use as a network address in communications within a network. Network address translation, NAT, the process of modifying IP address information in data packet headers while in transit across a router or firewall. Open Systems Interconnection, OSI, model, a conceptual framework that describes how data is transmitted across a network. It consists of 7 layers: physical, data link, network, transport, session, presentation, and application. Each layer has a specific function and communicates with the adjacent layers. Problem replication, a troubleshooting method that involves attempting to reproduce the problem to better understand what is going wrong. Protocol, a set of rules and standards that define how devices communicate with each other across networks. Protocols specify guidelines for formatting, transmitting, and receiving data. Troubleshooting approaches. 2. Remote troubleshooting tools, tools that let IT support technicians solve problems on devices from anywhere in the world. Root cause analysis, a problem-solving approach that focuses on identifying the underlying cause of a problem in order to address it, rather than just the symptoms. Transmission Control Protocol, TCP, a communication protocol that allows reliable transmission of data packets between network devices. Troubleshooting, the systematic process of identifying and resolving issues or problems. Troubleshooting best practices, a set of guidelines that IT support technicians follow when resolving technical issues. They help to efficiently diagnose problems, find solutions, and prevent similar issues from recurring. Troubleshooting methods, a structured approach for IT support technicians to use to navigate the complex landscape of technical issues. They enable the technicians to methodically diagnose, analyze, and resolve issues with both hardware and software. User Datagram Protocol, UDP. A communication protocol that allows fast transmission of data packets between network devices but does not guarantee delivery. Virtual Private Network, VPN, an encrypted connection over the public internet that allows remote users to connect securely to a private local network. An overview of troubleshooting. Page 1 of 2. Video transcript. An overview of troubleshooting. Imagine this scenario: Sam eagerly sits down to watch a movie on her favorite streaming service. The TV is connected to her home's router using Wi-Fi, but to her frustration, the video won't stream. How might Sam identify and resolve the issue? To identify and resolve the issue, Sam needs to troubleshoot the problem. Troubleshooting is the systematic process of identifying and resolving issues or problems. Successful troubleshooting involves a series of steps. The first step is to identify the problem. All Sam knows at this point is that she is unable to stream the movie despite being connected to the Wi-Fi. This is the symptom. Troubleshooters break down complex problems into smaller, manageable parts. Sam uses this approach to tackle her issues systematically. Next, Sam analyzes the problem. She checks other devices connected to the Wi-Fi and finds that they're functioning correctly. This tells Sam that the issue is not with the internet connection or the router. It narrows the problem down to her specific device. Next, it's time for Sam to generate a solution. Sam considers potential solutions, such as restarting her device, clearing the cache of the streaming app, or checking for software updates. Sam decides to implement a possible solution by restarting her TV. Then, Sam tests her first approach. After she restarts the TV, she launches the streaming app again. But Sam still can't stream the movie. Restarting the TV didn't work, so Sam develops a new theory. She suspects the software on the TV needs to be updated. She checks the settings and it does show that an update is available. Sam updates the software for her movie streaming app and then restarts the app. Sam keeps a record of her troubleshooting steps and outcomes. This documentation helps her track progress, learn from previous experiences, and easily revisit solutions if similar problems arise. Finally, Sam tests and verifies the solution. The video starts playing and now Sam can enjoy the movie. Sam has resolved her problem. Sam used troubleshooting skills to successfully resolve the issue that was preventing her from enjoying the movie. Sam should consider continuously learning and staying up to date with changes to her technologies. Technology is constantly evolving, and staying informed equips you with the knowledge and skills to tackle issues effectively. Page 2 of 2. Troubleshooting skills are essential for today's technology, whether you are an IT professional or someone facing everyday problem-solving scenarios. By following a systematic process of troubleshooting and using effective strategies, people like Sam and you can identify and resolve issues efficiently. What do you think? Employability skills. Critical thinking. How have you applied troubleshooting skills in your own life? Give an example of a problem you solved using troubleshooting skills, and the steps you used to resolve the problem. Evaluate your thinking. Does your answer account for the following? As you learned, troubleshooting is the systematic process of identifying and resolving issues or problems. Successful troubleshooting involves a series of steps, and you might need to revisit some of the steps as you troubleshoot. Troubleshooting tools. Troubleshooting in technology is like solving a puzzle. Puzzles are solved piece by piece, taking one step at a time. And this process involves different tools. One set of tools is physical, or hardware tools. These are tools that technicians use to analyze issues with devices such as a computer, smartphone, or network hardware. Another way to solve tech problems is through something called a command line interface, CLI. This is a more direct, text-based way to talk to a computer and tell it exactly what you want it to do. The command line interface is a piece of software that lets an IT support technician speak to a computer about hardware components, networking components, and software. Lastly, technicians use remote troubleshooting tools, which are like having a mechanic who can fix your car without even having to be there with you. These tools let IT support technicians solve problems on devices from anywhere in the world. Let's explore each type of tool in more detail. Hardware tools. IT support technicians use a variety of hardware tools when troubleshooting devices and software issues. IT support technicians can use hardware tools to resolve several issues. For example, if a computer or mobile device will not turn on, they need to use hardware tools to determine the cause and fix the issue. Select each marker, plus, on the following graphic to learn more about types of hardware tools. Screwdrivers. Screwdrivers open computer cases and other electronic devices. Multimeters. Multimeters measure electrical characteristics such as voltage, current, and resistance. They help diagnose issues with hardware components. Cable testers. Cable testers test the strength and connectivity of different types of data cables like Ethernet, high-definition multimedia interface, HDMI, or universal serial bus, USB, cables. Wireless network detectors. Wireless network detectors allow technicians to detect wireless networks in an area and analyze their signal strength. This helps with troubleshooting wireless connectivity issues. Network analyzer tools. Network analyzer tools monitor and analyze network traffic. They are software-based. Power supply testers. Power supply testers check whether the power supply unit of a device is supplying the correct voltage to the device. Flash drives. Flash drives can contain programs to install, update, or repair software, and they test the computer's ability to read data from USB ports. Hard drive enclosures. Hard drive enclosures allow technicians to access hard drive content without having to install it inside a computer. This is helpful for data recovery or diagnosing potential hard drive issues. Anti-static wrist straps. Anti-static wrist straps prevent static electricity from damaging sensitive computer components. Technicians wear them when working inside a device. Along with their knowledge and experience, these hardware tools allow IT support technicians to troubleshoot and resolve a wide variety of computer hardware issues. Hardware tools in practice. You've explored the various types of hardware tools IT support technicians use, but how are they used practically? The following scenario demonstrates how an IT support technician uses some of these troubleshooting tools. Introduction. Imagine that a dental office has been experiencing intermittent Wi-Fi issues all week, and they finally decide to call in Shauna, their trusted IT support technician. As Shauna walks into the busy office, she asks the receptionist to describe the issue. The receptionist explains that the Wi-Fi suddenly drops out, disrupting their online appointment system and slowing down the office workflow. Step 1. Wireless network detector. A woman uses a wireless network detector. Shauna immediately goes to work. To understand the Wi-Fi coverage throughout the office, she starts by using her wireless network detector. The tool reveals several areas where the signal is weak, including the front desk where the receptionist works. Shauna thinks this could be the source of the problem, but she needs to gather more information about the problem. Step 2. Cable tester. A woman uses a cable tester on a pair of cables connected to a router. To further investigate the cause of the problem, Shauna decides to use a cable tester to test the Ethernet cables connecting the Wi-Fi router to the main network. All the cables Shauna tests are in good condition, ruling out a cable fault as the cause of the issue. Step 3. Network analyzer tool. A woman typing on a computer with a graph on the screen. Shauna then turns her attention to the network itself. She connects her laptop to the network and uses a network analyzer tool to monitor the network traffic. The tool reveals high network congestion at certain times, which correlates with the times the receptionist said the Wi-Fi would drop out. Summary. With the information that Shauna gathers using her tools, she can determine the cause of the Wi-Fi issues and implement a solution. After she implements the solution, the dentist's office is back to running smoothly, and Shauna once again saves the day with her trusty set of tools and problem-solving skills. Hardware tools are an essential part of an overall toolkit that IT support technicians use to find, troubleshoot, and solve problems. The command line interface. The command line, also known as a terminal or console, is a text-based tool technicians use to control a computer. It's like using your computer with text commands instead of a mouse and graphical interface. You type instructions for your computer to follow, and it responds by showing text messages back to you. For technicians, the command line is an invaluable tool. They use it to navigate files, run programs, and even fix problems on a computer. While it might look intimidating at first, using the command line can provide a high level of control and precision, making it a powerful tool for troubleshooting and managing systems. Troubleshooting with the command line. The command line can provide large amounts of detailed information to IT support technicians to assist them in troubleshooting. Review the following cards to discover the types of information technicians can uncover using the command line. System information. The command line can provide extensive details about the system, such as the operating system version, hardware specifications, CPU, memory, disk usage, and so on, running processes, network configuration, and more. File and directory operations. The command line can list, search, and manipulate files and directories. This can help identify issues such as incorrect file permissions, disk space usage, or finding specific logs or error messages. Network diagnostics. Commands can test network connectivity, ping, view network traffic, netstat, query DNS records, ans lookup/dig, and more. Log files. Many applications and services output log files that can be accessed via the command line. These logs can often provide detailed information about errors or issues that the application is experiencing. Resource usage. The command line can provide real-time data about system resource usage like CPU, memory, and disk I/O. This can be helpful in identifying performance issues or bottlenecks. Service management. Many systems allow services to be started, stopped, or restarted from the command line. If an application isn't working correctly, it might be helpful to restart the service running the application. Software installation and updates. In some cases, software, drivers, or system updates can be installed directly from the command line, which can often give more feedback about the installation process than graphical tools. By using the command line's capabilities, IT support technicians can get to the root of problems more quickly and effectively, making it a useful tool in their troubleshooting toolkit. Remote troubleshooting tools. Today's IT support technicians can't assume that the devices and software they need to troubleshoot will be physically near them. Devices and software in modern organizations are located all over the world. To deal with this distributed technology environment, IT support technicians use remote troubleshooting tools when they are trying to resolve a problem over the phone or in a chat session. Check out the following table to learn about different types of remote troubleshooting tools. Remote desktop software allows IT support technicians to take control of a user's device from their own workstation, giving the technician the ability to troubleshoot in real time as if they were physically at the user's location. Examples include TeamViewer, Remote Desktop Connection by Microsoft, and Chrome Remote Desktop. Help desk software allows IT support technicians to manage and prioritize their workload by tracking issues reported by users, while also helping technicians collaborate on complex issues and maintain a history of solutions to common problems. Examples include Zendesk and ServiceNow. Network monitoring tools alert IT support technicians to issues such as a server going down or network performance degrading by monitoring network performance. Examples include SolarWinds and Nagios. Remote command execution tools allow IT support technicians to run commands on a remote machine without having to take full control of it. Examples include PowerShell remoting and Secure Socket Shell, SSH. Virtual private networks, VPN, allow secure access to a user's device or a company network over the Internet, enabling troubleshooting of network-related issues or software issues that require access to a secure network. Screen sharing tools allow a user to share their screen with IT support, which can be especially helpful when the user needs to demonstrate the issue they are experiencing. Examples include Zoom, Microsoft Teams, and WebEx. Cloud-based IT management tools provide a centralized way to monitor and manage devices and software across an organization, regardless of where the devices are located. Examples include Google Workspace Admin Console and Microsoft Intune. These remote troubleshooting tools ensure that IT support technicians can provide support even when they are not in the same physical location as the user. Remote troubleshooting tools can save both the IT support technician and the user a significant amount of time and make the troubleshooting process much more efficient. Troubleshooting best practices. Troubleshooting best practices are a set of guidelines that IT support technicians learn from others and from their own experience and follow when resolving technical issues. Best practices help to efficiently diagnose problems, find solutions, prevent similar issues from recurring. Troubleshooting best practices provide guidance on how to systematically break down a problem, making it easier to understand and solve. By documenting the issue, following a logical problem-solving process, and testing and verifying solutions, IT support technicians can ensure that they provide effective, reliable assistance. Following these best practices not only saves time and resources, but also increases user satisfaction and confidence in the IT support process. Explore each of these troubleshooting best practices in more detail. Gather information and document the issue. IT support technicians start by gathering information and documenting the issue by talking to users to get a description of the issue, observing the problem directly, if possible, reviewing any error messages or logs, documenting their findings for reference. Documenting findings makes it easier to identify patterns, repeat issues, and assist in future similar cases. Apply systematic and logical troubleshooting steps. IT support technicians approach the problem in an organized way, starting with the most simple and common solutions. Then, they gradually move to more complex ones, if necessary. This often involves identifying what has changed recently, reproducing the problem, if possible, isolating the issue by changing one variable at a time, test and verify solutions. Once a solution is applied, IT support technicians ensure that they have fully resolved the problem and haven't introduced new issues by performing some tests. This testing involves asking the user to perform the task that was problematic, monitoring the system or application for a period of time, running diagnostic tests, documenting the resolution for future reference. General troubleshooting methods. Troubleshooting methods provide a structured approach for IT support technicians to use to navigate the complex landscape of technical issues. They enable the technicians to methodically diagnose, analyze, and resolve issues with both hardware and software. These methods serve as a compass guiding IT support from the first report of an issue to its ultimate resolution. Imagine that a director's computer in a bustling financial firm suddenly stops working in the middle of an important meeting with a client. Without a systematic approach, an IT support technician might waste valuable time trying random solutions. But with established troubleshooting methods, they can calmly and effectively home in on the problem. They might begin by interviewing the director to gather crucial information, replicate the issue, isolate potential causes, and finally, apply a well-informed solution. A woman and man working together in front of two computer screens. Troubleshooting methods provide a lens through which to examine and solve technical problems. Let's examine some general troubleshooting methods. Problem replication. Often, IT support technicians will try to replicate the problem themselves to better understand what's going wrong. This could involve following the same steps a user took before a software crash or setting up a similar hardware configuration to identify a compatibility issue. Divide and conquer. In this method, the technician will divide the system or process into smaller, manageable parts to isolate the source of the issue. For instance, if a computer won't start, they might test individual parts, such as the power supply, RAM, or hard drive, one by one to identify the problem. Root cause analysis. This is a method of problem solving that tries to identify the root causes of faults or problems. An example would be analyzing log files or system events leading up to a server crash to identify what caused it. Experience. IT support technicians often use their knowledge from past experiences. For example, if they've encountered a similar problem before, they might try a solution that worked in the past. Research. If the problem is unfamiliar, IT support technicians might conduct research using resources like vendor documentation, forums, or a library of product documentation. For instance, they might look up an unfamiliar error code or symptom on a manufacturer's support site. Change management. This method involves looking at recent changes that might have caused the issue, such as new software installations or system updates. For example, if a computer started malfunctioning after a new software installation, the issue could be related to that software. User interview. IT support technicians often begin troubleshooting by interviewing the user experiencing the issue to gather information. For example, they might ask when the problem started, what the user was doing at the time, and whether the user has noticed any other unusual behavior. About this lesson, the CompTIA troubleshooting methodology. Have you ever found yourself lost in a new city, unsure of where to turn next? Much like navigating an unfamiliar location, troubleshooting technical problems can often feel overwhelming and confusing. But what if you had a map to guide you, a predefined path that ensured you wouldn't miss a turn? That's what the CompTIA troubleshooting methodology provides. This methodology gives IT support technicians a systematic approach to diagnosing and resolving technical issues. In this lesson, you'll learn about the key principles of the CompTIA troubleshooting methodology and when to use it. You'll also explore the steps of the methodology and apply the methodology to a realistic troubleshooting scenario. An overview of the CompTIA troubleshooting methodology. Think about trying to solve a large, complex jigsaw puzzle without having the reference image on the box. The puzzle is made up of hundreds or thousands of little pieces, each with a small part of the larger image. Grouping pieces with similar colors or patterns is a good strategy to start solving the puzzle, but without the reference image, it's extremely challenging to know what the result should look like. You might spend a considerable amount of time trying out different combinations, and while you might eventually be able to piece some sections together, it would likely take much longer than if you had the reference image. You'd also be working with a high degree of uncertainty, not knowing whether the piece you're holding fits where you think it does, or whether you're even on the right track at all. Similarly, in the early days of the IT support industry, technicians worked on problems without a standardized troubleshooting process, or reference image. They had to navigate complex and diverse IT environments, each with its own pieces in the form of various hardware components, software, and networks. Without a standardized troubleshooting process, each problem posed a unique challenge. IT support technicians approached these problems based on their individual understanding and experience, leading to variability in problem-solving efficiency and effectiveness. They relied heavily on trial and error, just like trying to assemble a puzzle without the box image. They needed a standardized framework in order to generate collective learning and improvement. Each IT support technician's experience remained siloed, and they did not systematically share or develop best practices. The introduction of the CompTIA troubleshooting methodology. The Computing Technology Industry Association, CompTIA, was founded in 1982 as a non-profit organization that aimed to standardize the growing IT support industry. As the IT industry continued to grow, CompTIA recognized the need for a standardized, methodical approach to troubleshooting and problem-solving within the diverse and complex computing environments that were emerging. The introduction of the CompTIA troubleshooting methodology provided that much-needed reference image for the IT support industry. It offered a standardized, methodical approach to problem-solving that IT support technicians could apply universally across different IT environments and issues. This methodology improved efficiency and consistency in troubleshooting and enabled better collective learning and continuous improvement in the IT support field. Just as having the box image makes solving a jigsaw puzzle more manageable and efficient, the CompTIA troubleshooting methodology provides a structured approach that makes IT troubleshooting a more streamlined and effective process. Key principles of the CompTIA troubleshooting methodology. The CompTIA troubleshooting methodology is more than just a series of steps for resolving IT issues. It's built on a set of fundamental principles that ensure its effectiveness and reliability. These principles work together to guide IT support technicians in approaching and solving problems in a manner that is thorough, efficient, user-focused, and forward-looking. Select each card to learn more about the CompTIA principles. Systematic approach. The CompTIA methodology encourages a systematic and organized approach to problem solving. By following a set of defined steps, IT support technicians can ensure they address every aspect of the issue, reducing the risk of misinformation or misdiagnosis. User communication. There is a significant emphasis on user communication. This helps to accurately define the problem and ensures solutions are aligned with user needs, thus enhancing user satisfaction. Thorough verification. An IT support technician verifies each step of the process, especially the implemented solution. This rigorous verification ensures that the IT support technician fully resolves the problem and that the system is operating normally. Preventative measures. The CompTIA methodology not only aims to resolve the current issue but also to implement preventative measures where possible. This proactive approach reduces the risk of future recurrence of the problem. Documentation. There is an emphasis on keeping comprehensive documentation. Documenting findings, actions, and outcomes facilitates knowledge sharing, future troubleshooting efforts, and continuous learning within the organization. These key principles, along with the steps of the CompTIA troubleshooting methodology, provide a comprehensive and effective blueprint for solving IT issues and enhancing overall system reliability. Steps of the CompTIA troubleshooting methodology. The CompTIA troubleshooting methodology provides a set of comprehensive, sequential steps. The sequential structure ensures a thorough and in-depth understanding of the issues, fostering a culture of long-term solutions rather than quick, temporary fixes. The steps start with identifying the problem, then implementing and verifying a solution, and finally documenting what you have done. Let's explore the steps of the methodology by reviewing a realistic troubleshooting scenario. Introduction. Imagine you're an IT support technician at a creative agency. One day, Jamie, a graphic designer, brings you his laptop. Jamie explains that their primary graphic design software is running slowly, frequently freezes and crashes, severely disrupting their workflow. You decide to apply the CompTIA troubleshooting methodology. Step 1. Identify the problem. Two people looking at a computer with a magnifying glass hovering over an application icon. First, you need to identify the problem. After asking Jamie a series of questions and observing the issue, you determine that Jaime's graphic design software is not functioning as expected, leading to a decrease in work efficiency. Step 2. Establish a theory of probable cause. A head with a light bulb over it, and a head with a conversation bubble coming from it. After listening to Jaime's concerns and examining the laptop, you use your knowledge and deductive reasoning to theorize that Jamie might be making too many demands on the software by opening too many large files at once. This suggests that there is not enough random access memory, RAM. You also theorize that the computer might need an update. Step 3. Test the theory to determine cause. An IT technician sits in front of a laptop while holding a checklist. To test your theory, you temporarily remove some large files and check for pending software updates. You notice a slight improvement in performance, which suggests that your theory that there might not be enough RAM is on the right track, but the freezing issue remains. Step 4. Establish a plan of action to resolve the problem. An IT support technician sits in front of a laptop while sitting on top of a roadmap. You establish a plan to further clean up the workspace, archive older files, and install a new RAM module to increase memory space. Step 5. Implement the solution. An IT support technician presses a start button on a laptop. Next, you implement your planned solution. You clean up the workspace, archive older files, and install the new RAM module. Step 6. Verify full system functionality and implement preventative measures. A green check mark on the laptop screen showing successful verification. Post-implementation, you use the software extensively, testing various functions and monitoring performance to ensure that you have truly resolved the issue. The software runs smoothly and quickly without any freezing or crashing. Step 7. Document findings, actions, and outcomes. An IT support technician typing on a laptop in a document that has a header titled Notes. Finally, you make a record of the issue, the steps you took to resolve it, and the final outcome. This documentation serves as a reference for future similar issues, potentially saving time and effort. Summary. By applying each of the 7 steps of the CompTIA troubleshooting methodology, you successfully resolved Jaime's software issue, restored their work efficiency, and documented the process for potential future reference. The iterative nature of the CompTIA troubleshooting methodology. The CompTIA troubleshooting methodology, at first glance, might seem like a linear progression, a sequence of steps that one follows from start to finish. However, the reality of troubleshooting in the IT field often requires a more flexible, repeat and adjust approach. As you proceed through the steps, you might find that the solution you've implemented doesn't fully resolve the problem. Or the theory you're testing might not accurately explain the problem. When this happens, the CompTIA methodology encourages you to circle back or iterate. If your solution doesn't fix the issue, you return to earlier steps. You might need to establish a new theory of probable cause, or perhaps your identification of the problem wasn't thorough enough. Solving the frequent crash dilemma, an iterative approach with the CompTIA troubleshooting methodology. Imagine that you are an IT support technician at a mid-sized technology company. One morning, an employee named Sarah comes to you with a complaint. Her computer frequently crashes, disrupting her work. Being proficient in the CompTIA troubleshooting methodology, you decide to employ it to solve Sarah's problem. 1. Identify the problem. You first speak to Sarah to understand the problem better. You learn that the crashes mostly happen when she's using a specific software application. 2. Establish a theory of probable cause. You hypothesize that the software might be incompatible with some recent updates to the operating system. 3. Test the theory to determine cause. You decide to test your theory by uninstalling the recent updates. Unfortunately, even after doing this, the problem persists. Was the theory correct? Your theory about what is causing the issue is incorrect, so you iterate and generate a new theory. This time, considering Sarah's heavy usage of the software, you suspect that her computer's RAM might be inadequate to handle the software's demand. 3. Test the theory to determine cause. You decide to test your theory by running the software that is causing the crash and using a system utilities tool to monitor RAM usage in real time. The RAM spikes and stays near the maximum while the software is running. 4. Establish a plan of action to resolve the problem. Your plan now is to upgrade Sarah's RAM to see if it resolves the issue. 5. Implement the solution. You replace the existing RAM with a higher capacity RAM module. 6. Verify full system functionality. After implementing your solution, you observe Sarah's computer while she uses the software. This time, there are no crashes, suggesting that your solution has resolved the problem. 7. Document findings, actions, and outcomes. Finally, you make a record of the initial issue, the actions taken, the unsuccessful theory, the successful solution, and the outcome for future reference. This iterative process is crucial in troubleshooting. It's not about getting from point A to point B as quickly as possible, instead, it's about fully understanding and addressing the problem, even if that means revisiting steps or theories you've already explored. Although the CompTIA troubleshooting methodology is indeed a series of steps, remember that these steps aren't strictly linear. They form a path that you might traverse more than once as you work towards the most effective solution. It's this iterative, flexible nature of the CompTIA methodology that allows it to be a powerful tool in resolving the wide array of issues that IT support technicians encounter. When to use the CompTIA troubleshooting methodology. Knowing when to use the CompTIA troubleshooting methodology is just as important as understanding how it works. Here are some common scenarios to help you apply this methodology. Diagnosing software issues. Imagine you're using your favorite application, and suddenly, it crashes. You try to reopen it, but it keeps closing unexpectedly. Here, the CompTIA methodology can guide you through a process of, first, identifying the problem, the application keeps crashing. Second, establishing a theory of probable cause, a recent update might be incompatible with your device. Third, testing the theory, uninstalling and reinstalling the app. Finally, verifying the solution, ensuring the app now works properly. Female IT technician holding document while looking at a computer. Resolving hardware malfunctions. Consider a scenario where a user reports that a printer in your office isn't working. Using the CompTIA methodology, you'd start by questioning the user to gather information, observe the printer's behavior, try out potential solutions, and verify whether you truly resolved the issue before considering it a closed case. Identifying network troubles. In this scenario, your entire office network goes down. The CompTIA methodology provides a structured process to help tackle even this daunting problem. First, it guides you to identify the issue: no one can connect to the internet. Then, it directs you to develop a hypothesis: the network server is malfunctioning. Finally, it focuses you to test and implement a solution: restarting or resetting the server, and, importantly, to verify network stability post-fix. Female IT technician checking network servers using a tablet. You might be wondering when to use the CompTIA troubleshooting methodology rather than a troubleshooting approach such as root cause analysis, problem replication, or even simply fixing the problem using knowledge from experience. Review the following list to determine whether you can use the CompTIA troubleshooting methodology to solve the issue you are facing. The problem is complex enough that it requires a methodical, step-by-step approach to ensure you have not overlooked any details. There is a need to involve a user or stakeholder in the problem-solving process. Understanding user needs and communicating with them is a key principle in the CompTIA methodology. The problem solution requires thorough testing and verification to ensure you have completely resolved the issue and to prevent it from recurring in the immediate future. There is a need to document the problem-solving process for future reference or to share knowledge with other members of the team. The problem-solving process will potentially reveal ways to prevent similar issues from occurring in the future. About this lesson, the Open Systems Interconnection, OSI, model. Network problems can be complicated, time-sensitive, and expensive to troubleshoot and fix. When faced with a network-related problem, it's helpful to have a systematic approach for diagnosing the problem, locating it in the network, and resolving the issue. In this lesson, you'll learn about the Open Systems Interconnect, OSI, model to divide the network communication process into 7 layers and how to efficiently identify and resolve problems. An overview of the Open Systems Interconnection, OSI, model. The Open Systems Interconnection, OSI, model is a comprehensive framework to diagnose and resolve network-related problems in various business contexts. It divides the network communication process into 7 distinct layers, each serving a specific purpose. The first layer is the hardware layer, and the rest are the software layers. Understanding each layer helps IT support technicians to efficiently identify and resolve issues within network infrastructures. This ensures smooth and reliable communication across a business interconnected systems. Each layer represents a specific aspect of data communication. IT support technicians use a bottom-up approach. They begin by investigating the physical layer and then move up to each layer until they find the source of the problem. Understanding each layer helps IT support technicians pinpoint the source of a problem effectively. Select each marker, plus, on the following diagram to learn how each layer of the OSI model works together. Start with layer 1 and work your way up to layer 7. Layer 1, Physical layer. The physical layer deals with the physical aspects of network communication, such as cables, connectors, and network interface cards. This is the only hardware layer in the OSI model. Any issues related to cable damage, loose connections, or faulty hardware fall under the physical layer. Layer 2, Data link layer. The data link layer concentrates on data transfer between 2 directly connected devices over a physical link. It handles tasks like media access control, MAC, addressing, error detection, and flow control. Troubleshooting at the data link layer includes examining issues with MAC addresses, network collisions, or misconfigured switches. Layer 3, Network layer. The network layer focuses on logical addressing and routing of data packets across multiple networks. Internet Protocol, IP, addresses and routers play a crucial role in this layer. Troubleshooting the network layer includes diagnosing problems with IP configurations, routing tables, or network address translation, NAT, issues. Layer 4, Transport layer. The transport layer is responsible for end-to-end communication between devices. It ensures data integrity, flow control, and error checking. Troubleshooting at the transport layer includes identifying problems with port numbers, firewall rules, or issues with transmission control protocol, TCP, or user datagram protocol, UDP, connections. Layer 5, Session layer. The session layer establishes, maintains, and terminates communication sessions between applications. Troubleshooting at the session layer includes tracking down issues with session establishment or interruptions in communication between applications. Layer 6, Presentation Layer. The presentation layer is responsible for data translation, encryption, and compression. It ensures that data is in a format that can be understood by the receiving application. Troubleshooting the presentation layer includes investigating problems with data formats or encryption/decryption processes. Layer 7, Application Layer. The application layer is the topmost layer of the OSI model. It's where end-user applications interact with the network. Troubleshooting at the application layer includes examining problems with specific applications, such as web browsers, email clients, or file transfer protocols. By following the OSI model and understanding the distinct responsibilities of each layer, network technicians can efficiently isolate and resolve issues within complex network infrastructures. This systematic approach helps ensure smooth and reliable communication across interconnected systems. Using the OSI model in business environments. IT support technicians use the OSI model to troubleshoot technical issues in different types of business environments across industries. Enterprise IT support. IT support teams often face a wide range of network and hardware issues. The OSI model provides a systematic approach for these teams to use to identify the root cause of problems. Suppose employees in a company's marketing department experience intermittent connectivity issues while accessing internal resources and the Internet. By following the layered approach of the OSI model, the IT support team can narrow down the problem's location and determine whether it lies in the hardware or software layers. Network Operations Center, NOC. Large companies have a NOC to manage and monitor large-scale networks, ensuring their continuous operation. The OSI model serves as a valuable tool for NOC engineers in dealing with incidents and maintaining network stability. For example, a telecommunications company's NOC receives reports of slow internet speeds in a particular region. The OSI model provides the benefit of systematic analysis, which enables the engineers to identify bottlenecks and implement appropriate measures to restore normal network performance. Network Security and Incident Response. Network security and incident response teams manage network security breaches and cyber attacks. Imagine that a financial institution experiences a cyber attack that results in website unavailability and service disruption. The incident response team would follow the OSI model to assess the situation. They would begin by analyzing the physical layer for any signs of direct attacks on the hardware infrastructure, like compromised routers or switches. Subsequently, they would investigate the next layers to detect any unauthorized devices on the network. As they progress to higher layers, they might discover the attack source IP addresses, which would help them implement appropriate measures to block the malicious traffic. In all these business contexts, the OSI model serves as a structured and systematic troubleshooting guide. Troubleshooting using the OSI model. When troubleshooting using the OSI model, IT support technicians investigate differently at each layer. While they review each layer individually, they also watch for areas in which the layers are interconnected. An issue in one layer might actually indicate an issue in another layer. Layer 1, Physical Layer. If an IT support technician encounters issues with network connectivity or data transmission, they would start troubleshooting at this layer. They would inspect and test physical components, looking for problems like damaged cables, loose connections, or malfunctioning network hardware. A physical layer issue, such as a damaged cable, can lead to data transmission errors and affect higher layers' reliability. Layer 2, Data Link Layer. IT support technicians investigate issues related to data transmission errors, data collision, or network interface card misconfigurations. If they find MAC address conflicts or problems with switches, they will address them at this layer. Problems in the data link layer, such as MAC address conflicts, can result in data collisions, impacting network performance and the ability to transmit data effectively. Layer 3, Network Layer. IT support technicians examine issues related to IP addressing, routing, and subnet configurations. Misconfigured routers or issues with network address translation, NAT, could impact this layer and lead to connectivity problems. If the network layer experiences issues with routing, it can lead to data packets taking inefficient paths, causing delays, and affecting the transport layer's ability to deliver data smoothly. Layer 4, Transport Layer. IT support technicians look into issues with port numbers, TCP/UDP connections, or problems with data segmentation and reassembly. If there are errors at this layer, it could affect data transfer and application performance. Transport layer problems, such as TCP connection failures, can lead to application-level errors and failed data transfers. Layer 5, Session Layer. If an IT support technician encounters issues with session establishment or disruptions in the communication between applications, they would focus on this layer. Problems here could lead to difficulties in maintaining sessions during tasks such as file transfers or video conferences. Session layer disruptions can cause application sessions to terminate unexpectedly, affecting user experience and productivity. Layer 6, Presentation Layer. IT support technicians examine issues related to data formats, encryption/decryption processes, or compression errors. If this layer encounters problems, it could impact the readability and security of transmitted data. Issues with data translation or encryption in the presentation layer can lead to data corruption or security breaches, impacting data integrity across the network. Layer 7, Application Layer. IT support technicians would focus on specific application-related issues such as web browsers, email clients, or file transfer protocols. Problems at this layer could affect the functionality and usability of applications. Application layer problems can directly affect user applications, resulting in application crashes, unresponsiveness, or data loss. As you've learned, the different layers of the OSI model are interconnected, and this impacts how IT support technicians might troubleshoot using the OSI model. Next, let's review a real-world scenario that demonstrates how technicians employ the OSI model layers to identify and resolve issues effectively. Troubleshooting using the OSI method in the real world. The following is an example of how an IT support technician can apply the OSI method to solve a real-world problem. Follow along as Alex, an experienced IT support technician, troubleshoots each layer to discover the cause of an issue. As Alex checks each layer, take time to consider what you think the problem might be. Scenario: Alex works for a medium-sized medical technology company. One busy Monday morning, the company's HR department contacts Alex, reporting that employees are experiencing frequent session disruptions while using the internal HR management software. The application keeps logging them out unexpectedly, causing frustration and impeding their work. Man leaning on a desk at a modern office. Alex promptly starts the troubleshooting process. Because the HR department is having issues with their network sessions, Alex believes the issue is likely at the session layer. But, knowing that a systematic approach is crucial in identifying the root cause, he decides to begin troubleshooting from the bottom layer of the OSI model, the physical layer. Layer 1, Physical Layer Troubleshooting. Alex arrives at the HR department's floor and checks the network connectivity. He finds no apparent issues with the network cables and connections. However, he does notice some electrical work being done nearby, which raises suspicions of potential interference. Alex decides to check all the network cables and network interface cards for any damage or disconnect ions, ensuring a solid foundation for the investigation. Layer 2, Data Link Layer Troubleshooting. After he has ruled out the physical layer as the cause, Alex moves up to the data link layer. He uses network monitoring tools to analyze data packets transmission patterns within the HR department's local network. While analyzing the data, Alex spots some irregularities in data collisions between two specific devices, which might be contributing to the session disruptions. Layer 3, Network Layer Troubleshooting. Suspecting that the data collisions might be a symptom of larger routing issues, Alex proceeds to investigate the network layer. Using the command line, he reviews the routing tables and configurations, ensuring that data packets are taking the most efficient paths. Alex also examines the router settings to confirm that they are functioning optimally. Layer 4, Transport Layer Troubleshooting. Despite improving data flow at the network layer, the session disruptions persist. Alex moves on to the transport layer, inspecting the TCP connections and port configurations. He confirms that there are no issues with the ports and that data segmentation and reassembly are functioning as expected. Layer 5, Session Layer Troubleshooting. With the physical, data link, network, and transport layers confirmed to be in good shape, Alex finally reaches the session layer. Here, he focuses on the HR management software's session establishment and management. Through in-depth analysis, Alex discovers that a misconfigured firewall setting is terminating sessions after a certain idle time, forcefully logging users out. Resolving the issue. With this knowledge, Alex reconfigures the firewall to allow for longer session idle times, accommodating the HR software's typical usage patterns. The session disruptions vanish, and employees can now work without interruption. By following a systematic troubleshooting approach, Alex successfully identified the session disruption issue and resolved it at the session layer. Even though he began at the physical layer, this method allowed Alex to eliminate potential problems in each layer systematically, leading him to the actual root cause. The OSI model provides focus and structure, which allowed Alex to pinpoint and fix complex network issues and ensure smooth and uninterrupted user experiences within the company. Adapting the approach. In certain situations, IT support technicians might need to start troubleshooting at a layer other than the bottom layer and then move up the OSI model. Although the OSI model's systematic approach suggests starting at the physical layer and moving up to the application layer, real-world scenarios can be more complex and could require a different approach. Here are a few reasons why an IT support technician might deviate from the bottom-up approach. 1. Known symptoms. Sometimes, the symptoms reported by the user or the nature of the issue might strongly suggest a problem in a specific layer. In such cases, it might be more efficient to start troubleshooting at that layer. 2. Previous incidents. If the IT support technician has dealt with similar issues in the past and knows that the problem often occurs at a specific layer, they might choose to start there to save time. 3. Limited access. In some situations, the IT support technician might have limited access or control over lower layers, making it more practical to start at a higher layer. 4. Time constraints. If there is an urgent need to restore services quickly, the IT support technician might focus on the layers that are most likely to be causing the issue rather than following a strictly systematic approach. 5. Network topology. The network's complexity, or topology, might suggest a specific layer as the likely cause, leading the IT support person to start troubleshooting there. Although following the OSI model's layered approach is generally the best practice for systematic troubleshooting, experienced IT technicians might use their judgment and adapt their approach based on the specific circumstances they encounter. Troubleshooting often requires a combination of knowledge, experience, and flexibility to identify and resolve issues effectively. Summary and looking ahead. In this lesson, you learned how IT support technicians use the OSI method to help troubleshoot network-related problems across 7 distinct layers. Layer 1, the physical layer, deals with the physical aspects such as cables and network cards. Layer 2, the data link layer, focuses on data transfer between 2 connected devices. Layer 3, the network layer, concentrates on the routing of data packets across networks. Layer 4, the transport layer, is responsible for end-to-end communication between devices. Layer 5, the session layer, establishes, maintains, and ends communication sessions between applications. Layer 6, the presentation layer, ensures data is in a format that applications can understand. Layer 7, the application layer, allows user applications to interact with the network. The next lesson explains the define, measure, analyze, improve, and control (DMAIC) approach for problem solving and improvement. About this lesson, the DMAIC approach. IT support technicians are expected to solve a lot of problems. Sometimes, their goal goes beyond solving the problem. They might need to make changes that result in lasting improvements. They will need to determine the exact nature of the problem, gather data to help identify the root cause and make and maintain improvements. In this lesson, you'll learn how technicians use the define, measure, analyze, improve, and control (DMAIC) approach to identify the problem, gather data to measure the current process, analyze the data to determine the root cause, implement solutions for improvement, and maintain those improvements. An overview of the DMAIC problem-solving approach. DMAIC, pronounced DMAIC, is an acronym that stands for the 5 steps that make up the approach: define, measure, analyze, improve, and control. It's an organized method for solving problems and making improvements. It was initially developed to improve manufacturing operations, and it's now used in many different fields, including IT technical support. Part of the Six Sigma approach, DMAIC emphasizes measurement and improvement. DMAIC starts with identifying the problem, continues with measuring and understanding the situation, and then moves on to enhancing and maintaining the improved condition. Overall, using the DMAIC approach leads to benefits for businesses such as reducing errors, improving performance, enhancing quality. Next, you'll explore the steps of the DMAIC approach. Steps of the DMAIC approach. DMAIC is composed of 5 steps in which IT support technicians begin by defining the problem, then measuring, analyzing the data, developing an improvement, and using controls to maintain the improvement. Let's walk through these steps. 1. Define. In this step, you identify the problem, goal, or process that needs improvement. This step is important because it sets the direction for the rest of the process. It is about understanding what you're aiming to achieve, defining the scope of the problem, and identifying the key stakeholders. 2. Measure. In this step, you focus on collecting data related to the current problem or process. This could include gathering information about the time it takes for a process, errors encountered, costs, or any other relevant metric. The purpose is to establish a baseline against which you can measure improvement. 3. Analyze. Next, you scrutinize the data gathered to identify the causes of the problem. You use root cause analysis to understand what's causing the issue. This step is vital for pinpointing the underlying issues rather than just addressing the symptoms. 4. Improve. In this step, you develop and implement solutions to the root causes identified. You might brainstorm potential solutions, select the most promising ones, and then test these to see if they improve the situation. 5. Control. Finally, you maintain the improvements made. This involves monitoring the problem or process to ensure that the changes are effective and lasting, and that the problem does not recur. The value of the DMAIC approach for troubleshooting. The DMAIC approach is based on the principle of continuous improvement, and this can be achieved through a systematic and data-driven process. The purpose of the DMAIC approach in troubleshooting is to help IT support technicians achieve 4 main objectives. Problem identification, root cause analysis, sustained improvement, transferability. Problem identification. Using the DMAIC approach, IT support technicians define the problem or goal, ensuring that they have a clear focus and understand what they need to address. Root cause analysis. With the DMAIC approach, IT support technicians seek to identify the root causes of the issue, not just the symptoms. This ensures that implemented solutions target the real problem. Sustained improvement. Using the DMAIC approach, IT support technicians monitor and maintain improvements. This helps ensure that changes are not temporary but result in long-term improvement. Transferability. IT support technicians can use the DMAIC approach for many different types of problems. Its versatility makes it a powerful tool for problem solving and process improvement in any context. The DMAIC approach gives IT support technicians another method for solving IT support issues that ensure sustained improvement. And it's transferable to different types of problems across industries. Female IT support technician with laptop in a server room. How is DMAIC beneficial? As IT support technicians move through each step of DMAIC, it's important to recognize the benefits of this approach. Structured approach. DMAIC provides a clear, step-by-step framework that IT support technicians can follow. This structured approach makes problem solving more manageable and less overwhelming, improving the likelihood of success. Data-driven decisions. DMAIC relies heavily on data collection and analysis, promoting decisions based on empirical evidence rather than guesses or assumptions. This makes solutions more likely to succeed and be effective. Continuous improvement culture. Because DMAIC encourages monitoring and continuous adjustment, it helps foster a culture of continuous improvement. IT support teams learn to always be on the lookout for ways to make processes better. Increased efficiency and quality. By reducing errors and waste and improving process stability, DMAIC can lead to increased efficiency and quality in processes, which can result in cost savings and improved outcomes. Summary and looking ahead. In this lesson, you learn the steps of the DMAIC approach and the benefits of this structured approach, which begins with defining the problem, relies on data for analysis, and increases efficiency and quality. You've completed the final lesson of this module. Next, you'll review the module's key points and explore additional resources related to troubleshooting tools and methods. Points to remember. Key concepts. 1. Troubleshooting is a vital skill for IT support technicians that involves the systematic process of identifying and resolving issues or problems. 2. Troubleshooting tools include hardware tools, the command line, and remote troubleshooting tools, each with their own advantages and applications. 3. Hardware tools include screwdrivers, multimeters, cable testers, anti-static wrist straps, power supply testers, flash drives, hard drive enclosures, wireless network detectors, and network analyzer tools. 4. The command line is a text-based software tool for controlling a computer. 5. Because devices and software in modern organizations are located all over the world, IT support technicians use a variety of remote troubleshooting tools to assist in diagnosing and resolving device and software issues. 6. Troubleshooting methods are structured approaches that help IT support technicians navigate complex technical problems. They include problem replication, divide and conquer, root cause analysis, past experience, research, change management, and user interviews. 7. The CompTIA troubleshooting methodology is a widely used framework that consists of 7 steps. Identify the problem. Establish a theory of probable cause. Test the theory to determine cause. Establish a plan of action to resolve the problem. Implement the solution. Verify full system functionality and implement preventive measures. Document findings, actions, and outcomes. 8. The Open Systems Interconnection, OSI, model consists of 7 layers. Layer 1, Physical Layer. Layer 2, Data Link Layer. Layer 3, Network Layer. Layer 4, Transport Layer. Layer 5, Session Layer. Layer 6, Presentation Layer. Layer 7, Application Layer. 9. IT support technicians can use the OSI model as a troubleshooting tool for networks by working up the layers to identify in which layer the problem occurs to isolate and resolve the issue. 10. The DMAIC approach is an organized method for solving problems and making improvements that can be applied to IT troubleshooting. It consists of 5 steps. Define. Measure. Analyze. Improve. Control. Big ideas. In addition, you explored or practiced these skills. You practiced choosing various troubleshooting tools, including hardware tools, the command line, and remote troubleshooting tools, to diagnose and resolve issues with hardware and software. You applied the CompTIA troubleshooting methodology by following the steps. You differentiated between the layers of the OSI model by choosing the correct layer for a given issue. You determined how to use the OSI model effectively using a bottom-up approach to troubleshoot and resolve a given issue. You applied the DMAIC approach to troubleshooting and resolve a given issue. Employability skills. Critical thinking. Identify the root causes of problems, establish theories of probable causes, and evaluate potential solutions. Analyze information from various sources, such as user reports, error messages, logs, and network data, to diagnose and resolve issues. Follow a structured approach to troubleshooting, such as the CompTIA troubleshooting methodology or the DMAIC approach. Communication. Use clear and concise language to describe problems, solutions, and actions taken. Adaptability and resilience. Adapt to different troubleshooting scenarios and tools, such as hardware tools, the command line, and remote troubleshooting tools. Overcome challenges and setbacks in the problem-solving process by using a structured approach and following best practices. Persist in finding solutions to complex technical problems, even when faced with obstacles or uncertainty. Analytical thinking. Analyze a troubleshooting scenario and the decisions made to arrive at a solution. Learning objectives. Now that you've completed this module, you should be able to choose a troubleshooting tool based on a scenario. Identify general troubleshooting methods. Apply the CompTIA troubleshooting methodology to a scenario. Apply the Open Systems Interconnection, OSI, model to a scenario. Apply the DMAIC approach to a scenario. Explore more resources. To explore concepts covered in this module in more depth, check out these resources. A Guide to Network Troubleshooting, Basic Steps, Tips, and Tools, opens in a new tab. This guide by CompTIA explains why troubleshooting skills are necessary for network management and shares basic network troubleshooting steps. Deciphering the OSI model of networking, 7 layers of bean dip, opens in a new tab. This article for Red Hat by Glenn Newell explains the OSI model using the analogy of a party food, the 7-layer bean dip. DMAIC process, the 5 phases of Lean Sigma you must know, opens in a new tab. This article by Steve Tanner for Simplilearn provides an overview of the DMAIC approach businesses take to improve their processes.